Okay, so we're starting with 4 different word problems. The word problems were given to some other students, make-believe people. And while trying to solve them, they made 4 different proportions that might work or might not work as answers, or not answers, as the process for how to solve these word problems. So your job is to just stare at the colorful answers and think about them, maybe talk with your neighbor and say which of these ones work. If I solve the proportion, that's good. And which of them are broken, they don't make any sense, the numbers come out wrong, they're dysfunctional. Some people got here early and have been looking at this a while. Let's talk about the first one. Which ones work for number 1?
Where are we at? Miles. The third one? I don't know. I'm just guessing.
No, don't just guess.
I don't.
Have some reason for your answer. So the first one, and why do you think the first one works?
Says you can drive 40 miles in 1 hour. I think.
Okay. Remember how we did math earlier this week to check proportions? If I do my diagonals, is 40 times 2 the same as 80 times 1?
Yeah.
Yeah, the numbers work too. But your intuitive sense is good.
Oh, and then the next one won't work.
The next one won't work. Okay. No?
No, that one works.
That one does work.
I always said the green one.
The green one. Okay, yes. So 40 miles compared to 80 miles is the same as 1 hour compared to 2 hours. And if we check them, yeah, 40 times 2 is 80 times 1.
Okay.
This one doesn't work.
No,
Because-
neither does it.
Because 40 times 80 is not 2 times 1. And for this one, 80 times 2 isn't 40 times 1. So see what we're doing? Okay, so spend some more time staring at the other 3. Which ones work, which ones don't. Are we ready for number 2? Okay, which ones work, which ones don't for number 2? Blue, and so blue, 12 times 3, 36 times 1. 12 tests to 36 tests is similar to 1 hour to 3 hours. Okay. And then green, 12 times 3 is 36 times 1. 12 tests to 1 hour, 36 to 3. That one doesn't work. 3 times 36 is too big. That one doesn't work. 12 times 36 is too big. Should we do number 3 or do you want more time? Everyone's okay with these announcements? Sort of 2 people doing all the work. So 220 to 1 pound is proportional to $11 for 5. Or 220 to 11, that's similar, like 1 pound to 5 pounds. Okay, last one. Which ones work, which ones don't? Green. $1.75 a day is like 455 for 260 weekdays a morning, weekdays a year.
And then the last one.
The last one. Okay. So, everyone happy with just the point of this exercise so far? Okay, so I want to copy everything and then make another version of it. And then paste these things on. And, oops. And get rid of okay, so let's look just at the ones that work, because we can learn from the ones that work. We don't want to learn things that don't work. In the first problem, it was the first two ones that worked. We have 40 miles in 1 hour and 80 miles in 2 hours. And I'm going to put a direction on those, just so it will help me in a moment. When I look at the ones that work, 40 miles in an hour was like 80 miles in 2 hours, or 40 miles in 1 hour is like 80 miles in 2 hours. I have parallel things going. So like many things in this class, there's more than one way to do it, and I'm always going to do it one way because for most people, one of these seems more natural, just the way our brains work. You can say, I have two situations, and then I put one situation on the right side of the equal sign, and the other one on the left side of the equal sign. For almost everyone, that's how our brains work. That seems right. That seems balanced. That seems symmetrical. You could also say, let's put one situation on top and the other situation on the bottom. That's perfectly valid. As we've seen in all these cases, there will be two that work. But for most people, this seems less natural, even though the math is fine. I say, this one is friendly, this one is confusing. If that's not you, if you like this one, you are fine. You can keep doing them this way. But I'm always on the board doing it this way, just because otherwise more people in the room have to press it. If we look at the ones that don't work, so 40 miles in an hour is like 80 miles in 2 hours. Now my directions are reversed. Those don't line up nice and symmetrical. Or if we have 40 miles in an hour, 80 miles in 2 hours, this is like Ghostbusters. Don't cross beams. Doesn't work. I could do the same for all of the others. So if I take away these things, then actually I'll put them back. I want to get rid of, I'll just get rid of everything actually. So 12 tests in 1 hour, 36 tests in 3 hours, 12 tests in an hour, 36 tests in 3 hours. So the good ones were the ones where everything is symmetrical, the arrows are going in the same direction. The bad ones either had the arrows in different directions or we were crossing beams. Everyone with me? So sometimes you can't just look at them because there's decimals or who knows what and say, oh yes, 40 times 1, 80 times 2, no, that's terrible. Sometimes you can't just eyeball the numbers and do the cross multiplying. So when you can't trust the numbers well, or maybe even if you can, then you can also look at the words. You want one situation on the left, the other situation on the right. If it's tests on top, it has to be tests on the top on the other one. If it's hours on the bottom, it has to be hours on the bottom on the other one. So everything is symmetrical. Unless you're one of the few people that likes just one and do that. That makes sense? Okay, so let's do a couple examples. If you can read 12 pages in 16 minutes, then, and at this point, I stopped reading the problem. I don't care what the rest of the problem says. I know if there's pages on top and minutes on the bottom, there has to be pages on top and minutes on the bottom. That's what I just learned. So I'm going to write that first, because about the only thing I could do wrong is accidentally flip those over. Does that make sense? So I'm not going to let the words confuse me. As soon as I write one side, I'm going to label the other. Okay, now I keep reading. How many pages, so that's my letter, can she read in 5 hours? Oh, they were trying to trick me. How many minutes are 5 hours? Yeah, 60 times 5, so 6 times 5 is 30, so 300. So again, let's talk about the good habits. When you start reading these proportion word problems, they will give you one situation clearly. As soon as you get that, put the words on the other side, and then fill in the blanks. If they're trying to trick you by having units that don't match, then fix that. Now we're good to go. This is the stuff we've done earlier. Y times 16 is going to be the same as 12 times 300. You don't have to write every line. We talked about what to write last time. And it's a word problem, so I label my answer. Okay, questions about that example problem? We'll do more.
Yeah.
Did I type it wrong?
2.5.
Ah, yeah, I just typed it in wrong on my calculator. Thank you for catching that. And that makes more sense. Any questions? Oh, let's do another one. So Maria drinks 4 cups of coffee every 5 days. So again, I have cups and I have days. So on the other side, I'm going to need cups and days. Now I keep reading. How many cups of coffee is this per year? So the cups is what I don't know. The year I want to change into days. So I can plug it in. Everyone okay with my setup? Now you might be asking me, so far these have been very contrived. It's been this number that needs modifying. What if she was drinking 4 cups per year, and this was the days, and we wanted to change that one to 365? So sometimes you might digit the other way too. You just have to make sure that the labels always match. Do you need me to keep drawing my ovals for cross multiplying, or is it okay if I move on from that?
It's okay.
So y times 5 on one side, 4 times 365 on the other. We're done. Questions about that problem? Okay. Let's do one more, but I'm not going to do it right away. You do it first, and then I will show you. So popcorn, 120 calories per serving. Oh no, that one, everyone's just going to multiply by 3.5. I need a better problem. Let's do that one. I just made a blank one. No, I didn't. Okay. So 5 mils of acetaminophen for every 25 pounds of weight, 80-pound child. How much medicine? What are my labels going to be? It doesn't matter which you put on top or bottom, but whatever you do has to be the same on both sides. If you flip them so that you have pounds on top and mils on the bottom, it'll work out exactly the same. But we have to pick one way for both. Okay, what is one situation? So I have one situation on this side. Actually, I'm not going to use that color. Use that color. And the other situation on the other side. So one situation is the general case, 5 mils for every 25 pounds. The other situation is 80 pounds, and we don't know how many. So y times 25 is 5 times 80. Okay, how many quarters in $4? $16, yeah. Everyone see why I said how many quarters in $4? We know how to do that. Okay. The next thing to talk about, I don't want to spend time on, but just to show you, maybe you noticed in this one that, hey, look, I can go times 5 here. So this one should be a times 5 also. What's 1/5 of 80? That would be my answer. Or maybe you noticed in, no, I guess we don't have an easy to see scale factor there. Anyway, so the way we did is always working and is nice. Sometimes, however, your brain, your eyes will just notice that one of these fractions, these is the reduced or unreduced form of the other. If I'm going 40 miles an hour or 80 miles in 2 hours, that's just the times 2 going sideways. If I had 25 cents to park for 15 minutes, how much would it cost to park 45 minutes? That's just the times 3 going across. So you can do them this way too. If you notice this, then it's fine. If you don't notice the pattern, you can cross multiply just like we did and everything is happy. So the official name for this is scale factor. And I don't want to do more example problems because they're just the same. But if you want to talk to your friend in a study group and say, oh, you did it the cross multiplying way, I noticed there's a scale factor of 3, then now you have that vocabulary. Yeah, scale factor. If you are having only geometric shapes, if you look in the textbook section that has triangles where one is big and one is small, but they're the same triangle, then we call those similar figures rather than scale diagrams. I don't know why. So there you go, good vocabulary. But today is Friday, so we're going to do a project. So in one of Eugene's park is a fountain or a pool or something with lots of goldfish in it. The goldfish are either red or they're white. So you are with Parks and Open Space, and you need to find out about how many fish of each type, each color, live in the pool. You get 10 fish that are black. These aren't going to mess up the ecosystem at all. You're going to put the black fish in, and then you know that there's 10 in there because you just did that. Then when you catch fish, you're going to use the information that you get, how many red and white and black, and try and figure out how many red and white were in the entire pond. People will get upset if you just catch 100% of the fish. Even if you're going to be nice to them, throw them out, it hurts the fish a tiny bit. Let's not traumatize the fish more than we need. So your solution can't be catch everything and count them all. So here is your steps. First, you're going to make a plan in your group. How many of the 10 black fish will you put in the pool? How many fish will you catch? Think about that. Then you're going to take your supplies. You're going to make a pond for another group. So actually, before we start this, you're going to come up here, take a bag and a card and 10 black beans. On your card, you're going to write the answer. So in the bag, you're going to put so many red beans and so many white beans, and write it down so that when the group is done, that you're handing this to, they can actually check their work. That makes sense? 40 and 15, write down 40 this color. Then trade bags with another group and take your 10 beans in your mystery bag and do the experiment. So put in as many of the black beans as you want. Pull out as many beans without looking at them, without looking at the paper inside, as your plan says. And then you have 3 equations to work with. One is the obvious one. If I add up the red and white and black fish, that's the total fish in the fountain. The other 2 are proportions. The ratio of a black fish caught to total fish caught will be the same ratio as the black fish in the fountain to the total fish in the fountain. If a fifth of them are black, then you expect a fifth of them are black, whether it's the ones you catch or the ones total. then the ratio with the red and the white. The red fish to white fish ratio for the ones you catch should be the same as the red fish to the white fish ratio for the total of the count. Same thing. They all mix around. So you'll plug in a bunch of numbers, because a lot of these are just things you count as you take the beans out of the bag. And do some cross multiplying stuff and see what your answer is. And then write a little bit. Make sense? So first, form your groups. And I can set up more than 6 supplies if we want more than 6 groups. I think that will be enough. I'm going to turn off the recording because it's going to get noisy.